Okay, today we're going to look at how to solve gravity problems. So quick review, less mass we figured out meant less gravity, more mass meant more gravity, and we had a graph line that looked like that when we graphed it using the PhET animation. And what that shows us is more mass means we get more force of gravity. So if one goes up, the other goes up. If one goes down, the other goes down. And when we first start to figure this out, we figure that y equals mx plus b for our relationship equation. But the thing is we can see that our y-intercept is 0, and the slope of that line is that 45-degree angle, or 1 over 1. So as we simplify that equation down, we get y equals x, where y is the force of gravity and x is the mass. So just like the axes here. So our x-axis is mass and our y-axis is the force of gravity. So what that means is whatever I do to the mass, if I multiply that by 2, I have to multiply this by 2. If I divide this by 7, I have to divide this one by 7. So whatever I do to the mass, I do the gravity. That's called a direct relationship. Whenever I do something to one, I have to do it to the other. In a mass problem, you're going to see the units of kilograms or grams. And units for force of gravity are always in newtons. So that'll help me identify what part of the problem I'm looking at. You'll also notice as we go through here that we will most times try to make a math model. That just takes some of the information out of our brains and gets it on the page in front of us to make life a little bit easier. So what you're going to see me do is draw kind of a barbell shape and then just drop the information from the problem into the model. So this one tells me that the force of gravity is 5 newtons. So I know that's that line in between. So you could draw it like a force arrow if you wanted. And it says the mass of one of these objects is doubled. And so because I know that y equals x, if I have 2 times the mass, then I have to have 2 times the gravity. So I'm just going to take this 5n, oops, try that again, 5n, and I'm going to multiply that by 2. So 5n times 2 equals 10n. I will have 10 newtons of gravity. So that works for anything. If I have 3 times more mass, I have 3 times more gravity. If I have 5 times more mass, I have 5 times the gravity. If I have half the mass, I have half the gravity. So your problems, though, might not quite look like that. So we have a kind of a simplified steps to solve the problem right here. I will always make sure that I figure out how the mass changed and make sure I'm always multiplying or dividing. I'm never adding or subtracting. And then I multiply whatever I get from that step 1 by the original force of gravity. So let's give it a shot. So it says force of gravity between 2 objects is 6 newtons. And the mass of both objects is doubled. So I'm going to multiply this one times 2. And I'm going to multiply that one times 2. So I'm going to grab this original force of gravity, and I'm going to multiply it by 2. For that particular image, 6n times 2, that gives me 12n. But then I still have to multiply, I still have to change this mass, so I'm going to also do that one. 12n times 2, I then get 24n. So 24n is my total. Now you might have decided, well, 2 times 2 is actually 4. So you could have taken 6n times 4 and gotten the same result. That's okay too. So that's one way you might see a problem. Another way is here on this bottom one. So let's look at that one really quickly. A supply vessel left Earth on the way to ISS, and its original force of gravity is 600,000 kilograms. And the force of gravity between that and the Earth was 18 newtons. After dropping the supplies and returning to Earth, the mass of the vessel was 200,000 kilograms. So I've got to figure out what had to happen? How did we get from there to there? And remember, it's always multiply or divide. It's never add or subtract. So what would I have to multiply by or divide by to get from 600,000 to 200,000? Well, I am going to be dividing by 3, right? And whatever I do to the mass, I have to do the same thing to the gravity number. So all I'm going to do is take this 18N, and I am going to then divide it by 3, and I get 6 newtons. 6 newtons of gravity. Now the question we ask ourselves as students is, did I get it right? Right? So first thing to notice is these numbers are super huge. We don't want this to be about your ability to use scientific notation, so we made the gravity numbers friendly. So the second thing you're looking for is it easy math? I can plug this into a calculator, or I can do this in my head, and I ended up with a friendly number 2. So that means I'm probably got it right. The second thing I'm looking for is, did it do what I expected it to do? So if my mass went up, did my gravity go up? Or if my mass went down, did my gravity go down? In this case, my mass went down because I dropped off some supplies. So I should get a number that's less than 18 newtons, and 6N is less than 18. So because it was friendly and it did what I expected, I can be pretty sure I got this one correct. So you're always looking for those two things on a gravity problem. All right, so that's your mass examples. Distance, on the other hand, we discovered was a little different, right? We figured out less distance meant more gravity, and more distance meant less gravity. And we had a graph shape that looked like that. And so if I think about this relationship right here, less distance means more gravity, or more distance means less gravity. So that is called an indirect relationship when those arrows go in opposite directions. And when we figured out our equation, what we said was, in order for this line to kind of come down this direction, it had to be an inverse. So we had to have 1 over something. And then to get this beautiful curvy shape, it had to have an exponent, which we know is x squared. So if you're a mathematical person and you can plug any number in the world into this and chug out an answer, great. If you're like, the idea of this square inside of a fraction kind of freaks you out, don't worry, we got you. Because our process is going to be to flip and square it. Flip and square it. You can say it like you're mad. You can say it like you're prim and proper. Flip and square. I don't care how you say it, but that's kind of the process we're going to use. To make sure it's a distance problem, I might be looking for meters, kilometers, or something big like a light year. Those are all units of measurement of distance, and so I might look for something like that. And again, that unit for force of gravity is always going to be a Newton. So in order to do this and break it up into steps, we have provided those here for you right here. So there's your steps. Those are your steps to solve a distance problem. So we will figure out what happened to the distance and how that distance changed. And again, we are always going to multiply and divide. We're never going to add or subtract. We're going to flip the number over or find the inverse. We're going to square that number, and then we're going to multiply by the original force of gravity. The kicker is how we think about distance and how it affects gravity. We have to remember to flip and square it. But if it's closer, we always start with a fraction. And if it's farther, we always start with a whole number. So we're going to practice just steps 1 through 3 first to make sure we get it. And again, we're going to use those math models to make sure that we can take some of the work out of our brain and put it into our eyeballs. So this first one says, We have these two objects. We don't know what the force of gravity between them is, but I'm going to double that distance. So I'm going to make it a lot farther. So if I have 2 times the distance, okay, so I know my distance is times 2. So my distance is 2. I have to find the flip of that number. So 2 is like saying 2 over 1. So my flip is going to be 1/2. So once I have that 1/2, I'm going to take that 1/2 and I'm going to multiply it by itself, and I get 4. So I know there's going to be at least 4 times the amount of gravity. So if I look at 3 times more distance, so I'm always going to use that distance flip square kind of steps. So 3 times more distance, if I flip that number over, I get 1/3, and I square that number, I get 1/9. I would have 1/9 the amount of gravity. On that next one, same process, 5 times more distance. I'm making things farther apart, so if that's 5 times more distance, that flip becomes 1/5, and the square becomes 1/25. But if I start with less distance, or 1/4 of the original distance, I'm going to start with a fraction. So if it is 1/4 the distance, it's closer. My flip becomes 4, and my square becomes 16 times the amount of gravity. And same thing for that last one. If it's halfway closer, half the distance, my distance is 1/2, my flip is going to be 2, my square is then going to be 4, and I would have 4 times the amount of gravity. So let's go ahead and then put all of those pieces back together. So if I'm going to make that math model. So the first one says the force of gravity is 8 newtons. And when you're making your math model, it doesn't matter. Do I put it at the top? Do I put it at the bottom? I'm just getting that information in front of my eyeballs. It says the distance between the objects is doubled. So I don't even know how far it is. It just says it's twice as far as it was before. And so whatever that distance was, it's now 2 times the amount of distance. Well, that's handy because that's my distance number, right? It's twice as far. So my flip is 1/2. 1/2 times 1/2 is 1/4. That's my square. So then I multiply my 1/4 by the original force of gravity. So that's my original force of gravity from the problem. So I'm going to take 1/4 times 8n, which is the same as saying 8n over 4. So if I simplify that down, I get 2n. So again, did my gravity do what I expected it to? I got farther away, so I would expect there to be less gravity. So is 8 bigger than 2? Yes. Because it is of the square value, I should know that should be a lot less, and 2 newtons is a lot less. Even though these numbers aren't very realistic, that would still be a lot. So let's try it again. 2 objects are 5 meters apart. This time it does tell me how far, so I'm going to write that down. The gravity is 18 newtons. So again, notice I didn't pay attention. I don't care where I'm writing it. I just am getting it on the page. So what's the force of gravity if they are moved to 15 meters? So now what I have to, and I'm trying to figure out this number. So now I have to figure out what happened right here. How did I make that distance go from 5 to 15? Well, to take 5 and turn it into 15, I have to multiply it by 3. So my distance is 3 times. The other thing I'm looking at is it closer or is it getting farther apart? So this one I know is getting farther. So if I go back up here, farther means start with a whole number. So that's the other reason why I know to start with the number 3. So the flip of 3 is 1/3. The square of 1/3 is 1/9. I'm going to take 1/9 times the original force of gravity. So the original force of gravity is that 18 newtons number. So 1/9 times 18 newtons, that's the same as saying 18 newtons divided by 9, which that equals 2 newtons. It was friendly. I could do 18 divided by 9 pretty easy in my head or punch it into a calculator. Did it do what I expected? It got farther away, so it should be a lower number than 18, and 2 is a lot less than 18, so I can be pretty sure I have a correct answer. Huh, weird. They both equal 2n. It's not always going to happen that way. All right, so let's try your last example. A rocket is landing on a landing pad in the ocean. When it is 100 kilometers away, so there's the first number, the force of gravity is 5n. What will be the force of gravity when it's 25 kilometers away? So when they're landing those, they got to know what the force of gravity is so they know how much to fire off those rockets. So I've got to figure out what happened to make 100 turn into 25. What did I have to multiply or divide by? So here I'm looking at this going, oh, I divided that by 4. And again, do I start with a whole number or a fraction? This got closer, so I'm going to start with a fraction. The other thing that told me I'm going to start with a fraction is I had to divide to get there. So my distance is 1/4 the distance. I'm going to flip that fraction over to be 4 over 1 or 4. 4 times 4 is 16. So then I take 16 times the original force of gravity. The original force of gravity is that 5 newtons. And I don't know that answer. So 16 times 5 equals 80 newtons. So there you have it. That's how you solve gravity problems.